First, we're going to teach a renashaw probe, the datum point of this particular job. So this particular job, we're using this corner here as our datum. A little bit more information on the drawing. It's telling us the blank size is 255 by 100 by 20. So this part ends up 6.5 thick, so we've got quite a lot of material to take off the face. We've got 2.5mm per side on the length, and we've got 18mm to 9mm per side on the width. So we've got a little bit of material to take off the sides as well. So we're going to teach the probe this corner here from the billet. So we're going to teach it that it's got my 2.5 material on this side and 9mm material on this side here. We're also going to tell it that it's got 2mm to come off the face. So to get to a probe program, we're going to auxiliary process, NC program. So our subroutines that have been registered here in our NC language, we've only got 3 of them. We'll go through and see which one fits the best. So we've got our Y centre line X left, so that would be teaching if the datum is through the centre. Our datum's not through the centre, so that doesn't apply. 3-point call is for teaching circles, obviously not a circle. X left and Y front. So this particular process is going to teach the X left hand side, so it's going to teach our datum over this side, but it's also going to teach the front. So this actually the movements that we want are in this subroutine. We just need to manipulate it a little bit. So we'll call that up. So we've got it registered here. This is our code that's been registered in that soft key. So we come down, we check to see what work offset we're using to make sure that we're currently using G54, so that's correct there. We're doing a little bit of a movement here on our probe while the spindle's still at home in Z, so it brings it over X20 and Y minus 10 in Y. And we come down and we read the program here. Our subroutine code here, G65, is pulling up a macro program. Our P9810 is how we move the probe around off the job whilst looking at the probe. So if the probe stylus bumps into anything because of an error we may have made or material that's not there, the probe will actually stop without damaging anything. So we always make sure that we're moving the probe around with this 9810 command, and that way you minimise the risk of damage to the probe if there's any errors. So we come down here, so our first line here is going, just go back to our first line. Our first line here is X20 minus 10, so that's actually going to bring the probe over to 20mm over here and minus 10 here. Just need to see what that's doing to start with, so we're going down here to teach Y. So in this case, the positive 20 is actually incorrect because there's no material over here. So we need to look at our movement here of X20, and we need to make that X minus 20. The reason we're making it minus 20 is because this code that's been registered was to teach this edge, the left hand side. We want to teach the right hand side. So we've got to bring it over. So our X0 is along this face, so we want to bring it 20mm this side of this face. Y minus 10, we have got 18mm of material to remove off this job, so Y minus 10 might not be sufficient, because if we're slightly off on our rough teach and 0, that's going to bump into the material, so we'll make that minus 20 just to be safe. We're then coming down, the next one we're looking for is our Z movement, so this is going to position the Z, the probe 6mm below our Z0. So that'll actually be 8mm below the material because we've got 2mm to take off. That's taking it beyond the radius of the probe, so that's perfect. That's exactly what we want. Here our P9810 is going to teach a reference face of one axis. So in this one we're doing the Y axis. We've got a pre-registered value here of 0. Now that's not going to be any good because we've got 9mm of material. If we left that at 0, then we'd end up with the job all offset and we'd have trouble cleaning up this face. So we need to alter that to Y minus 9. So when the probe touches that edge, it's going to teach the machine that it's 9mm away from its reference point. G54 reference point. So it'll put a -9 value in there. Q10 is our tolerance. We've got 9mm there. We're 20mm away from the job, and we're at 20mm away, which gives us 11mm, and we've got a 10mm tolerance. So we might just increase that a little bit. Just give us a little bit come and go on the material size. And we're teaching the G54 coordinate with our S1. From here we're going to move up to Z5. Now we've got 2mm to take off the job, so Z5 will definitely miss. However, we'll just increase that just to be safe to 10. So that's going to bring the probe back up to Z10. We're then positioning, our next line is going to position the probe at 62 and X20 in preparation to teach the Z axis. Our X20 again is incorrect because that's out here. We'll just change that to X minus 20. And Y62 is well and truly in the material, so that's sufficient. We have 2mm to take off the job, so when we come down and teach our Z on our P9811, which is our single axis reference base, we can put a value in there of Z positive 2. So when the probe comes down and touches the job, it'll teach the G54 that the probe is actually at 2mm. We have a tolerance again of 10, which is sufficient for your Z-axis, and a offset. We're using the offset S1, which is G54. When we come down here, have a look a little bit further, just got a few lines up so we can see them. We're moving to X minus 10 and Z minus 4. Now, before our minuses were positives, so because we're on the opposite side of the job, we need to make that positive so it doesn't bump into the material. So we're going to make that X10. So it'll come out 10mm on this side of the job in preparation for its Z move. It's going to move down to -4, which is sufficient because we've got 2mm material, and again it's past the radius of the ball on the end of the probe. So this is where we're teaching our line, our P9811, reference base single axis, and a value of X0. Again, we don't want to teach it at 0, we actually want to teach it that it's -2.5, or positive 2.5. So we're going to type in there X2.5, alter. We have a tolerance of 10mm, so we're 7.5mm away from the potential material, so that should be sufficient. And our work offset of S1. Checking that we're going to bring the tool up high enough, that the probe top high enough off the job after it's done its teaching, Z100, and then taking it home. So that's your probe finished. M145 probe off and skip off. So that's ready to go.